All right, now let's look at the polar part of our test review. Question number 4, first thing it asks us to do is identify the polar coordinates of point M and N. Now, I've just drawn a sketch here on my screen. You'll need to look at your test review and see the graph so that you can actually see what these coordinates should be. But let's start with point M. Remember that polar coordinates should be given in the form of a radius and an angle. So for question M, if you can count those circles that lead out to point M, there are 4. So my radius is 4 because M is located on the 4th circle. And then if you look at the angle measure there, 7 pi over 6. For point N, if we count those circles, there's 5. We have a radius of 5 for point N, and then its angle is pi over 2. So that's part A for question number 4. Now part B asks us to determine the rectangular coordinates for those same points. If you look in your foldable, you've got some formulas that will help you do this. To find the x coordinate, we're going to do r times cosine theta. And to find the y coordinate, r times sine theta. So let's do that. For point M, my rectangular points are going to be 4 times cosine, and we have the angle in radians, 7 pi over 6. If you would prefer to change it to degrees to put in your calculator, that would be fine. 7 pi over 6 is the same as 210 degrees. You can use the radian angle as well. Just make sure that your calculator is set for radians or for degrees, whichever one you're using. And then my y coordinate would be 4 times sine of 210. So I'm going to put that in my calculator, and I get negative 3.464 and negative 2. Now both of those came out negative because if you notice, point M, it is in quadrant 3. And so both of my coordinates, my x and y coordinates, should be negative. And we need to do the same thing for point N, and you could use the formulas again if you want to, but if you just look at the location of N, we can actually get the rectangular coordinates just from the graph. N is on the y-axis, and so that means that my x-coordinate would have to be 0. And the y-coordinate, remember that my radius is 5, and that would be my y-coordinate. N is located 5 units above the pole or above the origin. And so we just get 0, 5. Now if you use the formulas, you would arrive at the same answers. Now on question 5, they're giving us rectangular coordinates of a point and asking us to convert that point P to polar coordinates. We have formulas for this as well. If you look at your foldable, you can find the formulas. To get my radius, it's really just, you know what, I'm going to actually draw a picture first. Let's plot this point. Negative 2 square root of 2, 2 square root of 2. That's going to be in quadrant 2. So this point would be about right here, and I'm just going to draw in this triangle. So we know that this side is negative 2 square root of 2 and this side is positive 2 square root of 2. So to find my radius, which is going to be the length of the hypotenuse of this triangle that I've drawn here, radius squared is going to be equal to my x coordinate squared plus my y coordinate squared. So r squared is equal to 16, which means that r equals 4. And really, I'm going to put plus or minus 4 because we could choose to use a positive radius or a negative radius. The next thing that we need is an angle, a direction for this point. And if you notice in my triangle, I've got 2 sides that are the same, which means I have an isosceles triangle. And so based on that information alone, I know that this angle inside here has to be 45 degrees. This has to be a 45, 45, 90 right triangle. But if you didn't realize that, we can still use our formula. Theta, and again, like I did with the vectors, I'm going to call this theta reference. This is our reference angle, and that's going to be inverse tangent of y over x. So 2 square root of 2 over negative 2 square root of 2. And if you put that into your calculator, it's going to give you negative 45 degrees. So see, we get that same 45-degree reference angle. But for this angle here, I really need this outside angle. And so my actual theta is going to be equal to 180 minus 45, or 135 degrees, which is the 45-degree angle in quadrant 2. They ask us to graph point P on the polar graph, and you can do that on your grid. It should be on the angle 3 pi over 4, 135 degrees. That's equal to 3 pi over 4 radians. So the point should be on that spoke, and the radius we figured out is 4, so it should be 4 circles out on the 3 pi over 4 spoke. And finally, question C asks us to write 2 other pairs of coordinates for the same point. Now remember, with polar graphing, you can have multiple coordinates for the same point. So I'm going to redraw our point over here, and remember that it's 135 degrees. And I'll draw this in just for reference. So one thing I could do to write different coordinates, here's part C. Instead of using the positive 135-degree angle, I could use the negative angle. And that angle would be, that coterminal angle would be 360 minus 135, which is going to give me 225 degrees. So one way I could write the coordinates would be a radius of 4 and a negative 225-degree angle. Now another thing I could do is use a negative radius. And if I'm going to use a negative radius, I'm going to have to start my picture over again. Here's my point out here, 135. If I want to use a negative radius, that means that my angle needs to be the angle, the same 45-degree reference angle, but in quadrant 4. And that angle has a measure of 315 degrees. So directly across from 135 is 315. And so if I use 315 as my, sorry, I'm writing on the watermark again. If I use the 315 degrees as my angle, then I want my radius to be negative 4, so that it sends it from the 4th quadrant into the 2nd quadrant. And those are just 2 possibilities. There are other correct answers. Let's move on to question number 6. In question number 6, we're asked to use our graphing calculator and draw a sketch of this graph. R is equal to 4 sine of 3 theta. Now you're going to be able to use your calculator to help you get a sketch of this graph on the test. You're going to put your calculator in radian mode and then enter in that equation. So if you want to pause the video for a moment and try that right now, and then come back when you're ready. And what we end up with here is one of these flower graphs. It is centered on the excuse me, I'm sorry. It is centered on the negative y-axis. And so your graph should look something like that when we sketch it. The important thing here is that because there's a 4 here in front, this petal right here, it should reach down to negative 4 on the y-axis. Alright, let's move on to question B. In question B here, we're given a polar equation. R is equal to -3 over 2 cosine theta, and we're asked to convert this to a rectangular equation. Whenever you're converting from polar to rectangular equations, one of the main things that we're trying to do is, if we have a cosine or a sine, we need to get it to be multiplied by r. Because if you look at your foldable and you look at your formulas, we know that x is equal to r cosine theta, y is equal to r sine theta, and so I need to have one of those to be able to convert to x and or y. So in this case, I've got r over here on the left, and I'm dividing by 2 cosine theta. And so what I can do is just multiply that 2 cosine theta to the other side. I can multiply both sides by 2 cosine theta. And so I end up with r times 2 cosine theta is equal to -3. And it might be a little more convenient if I wrote that as 2r cosine theta equal to -3, just switching the places on the 2 and the r. And then right here you see r cosine theta, and my formula tells me that that is equal to x. So 2x equals -3, and now I have a rectangular equation. No more r's and thetas, only an x in this case, but we could have x's and y's to make it rectangular. Final question here on our review, question number 7, is asking us to take a rectangular equation and convert it to polar. So I have x squared is equal to 5y. Now we have our same conversion formulas. X is equal to r cosine theta, y is equal to r sine theta. And those are the formulas that I'm going to use. For x, I'm going to plug in r cosine theta, but that needs to be squared. And then on the other side, 5 times, and instead of y, I'm going to plug in r sine theta. And typically with polar equations, we want them where it's r equals everything else. We want to have r by itself. So we need to try to get this where we have r by itself. So I'm going to go ahead and square this on the left, and I get r squared times cosine theta is equal to 5 times r times sine theta. Now I notice that I've got an r, at least one r, on both sides of the equation. So what I'm going to do is divide both sides by r. And notice this one over here on the right cancels out. I'm just left with 5 times sine theta. And over here I had r squared over r, so one of those r's cancels out. And now I just have r times cosine theta. And so my final step to get r by itself, I'm going to divide both sides by cosine theta. So those cancel out, and r is equal to 5 times sine theta over cosine theta. And that brings us to the end of our test review.